Hey you guys, this is a quick lesson on graphing quadratics in standard form, so thanks for watching. Don't forget to like, comment, and subscribe. Changing a quadratic in vertex form, and we did talk about this in the last section, is if it's not in vertex form, we may have to use completing the square stuff. Now again, completing the square, we need the coefficient of x squared to be 1 and not anything else, okay? So if we need to force it to be 1, we can. I don't know. Those are very general steps, right? Divide all terms by a just to get the coefficient of x squared to be 1. Use the form x squared plus bx, just that part to complete the square. Now remember, whatever you add or subtract, well, you're going to be adding to that to complete the square. You'll have to subtract it off if it's on the same side, which it will be. Okay? Add c to k. Yep. And that would give you your final k value. Add c to make k. There you go. So we need to change this equation into the vertex form, which we will. But let's separate things just so we have it, nice and neat. So I got that x squared plus the 2x. But I want to separate that minus 3. Okay, so that I can complete the square. Which means I'm really just focusing on this portion of the equation, right? So that I can complete the square. And to do that, I look at the b value of the parentheses now, the green, which is 2. And I would need to divide that by 2 and square it to complete the square. Now when I do that, I get 1 squared, which is just 1. So I add that 1 here. Now this is on the same side of the parentheses. So since I added 1, I also need to subtract 1 as well. Well, we know from the completing the square stuff, whatever was inside the parentheses squared, and that's what we added, the 1 there, which I put in orange now. That's going to change this, right, into x, and then that was a positive 1 inside that parentheses. We're going to square that, and then we're going to combine these two. Negative 3 minus 1 is negative 4. And this equals y. That looks like vertex form to me. And, if you want to show the a value is 1, so be it. But at least on the test, it's not necessary that you do that. So with graphing, once again, if we can just find the vertex, and if it's in vertex form, it makes it extremely convenient. And then from there, we'll just expand out a couple points, and that's all we'll need for graphing by hand. All right, so let's graph this. We'll find the vertex, which we'll need anyways for the graph. And that may help us to see this plus 0 stuff, right? Because it's a phantom 0 when we add or subtract. Well, this should help us to see that the vertex, and yeah, that should be x minus h, but it's plus 2, so we're just going to make it minus negative 2, so that it would be plus. So we get the vertex at h value of negative 2, and then the k value is at 0. And we can graph that, negative 2, 0, right there. Let's go ahead and throw on the axis of symmetry on the graph, just I don't know, maybe it'll look pretty. Now the a value that we have is a negative 1, so we should expect this to open down, something like this right here. Let's find some more exact values, right? So let's go to negative 1, and again it's symmetric, so whatever point we find, it'll just be reflected across that axis of symmetry. Negative 1, so I got y is negative of negative 1 plus 2. We'll square that, and so y is negative of negative 1 plus 2 is 1 squared. So y is negative 1. So when x is negative 1, I get y at negative 1 as well. And since we have the axis of symmetry, and this is 1 unit to the right of the axis of symmetry, the other point would be 1 unit to the left of the axis of symmetry. So we got these two purple points right there. All right, I'm going to try where x is 0 then, on the y-axis. x is 0. So the equation, and 0 plus 2 is 2 squared. So the negative of 2 squared, which is 4. Y is negative 4. So at 0, I got negative 4 right there. Now again, this is 2 to the right from the axis of symmetry, so I got to go 2 to the left to find its reflected point. And then we got, something that looks like this. Now again, as long as you have those points on an exam, and you've shown the work for them, you're in good shape. Just in case, if it did ask for the equation for the axis of symmetry, it's always x, at least for now, it's always x equals whatever the h value is, and that was negative 2, if it asked for the equation. More graphing, we'll find the vertex in the axis of symmetry. We'll do the equation. Once again, if it helps us, we can see that plus 0 stuff, which helps us find a vertex. And once again, we got x plus a value, but it should be x minus h. So we are going to make that minus a negative 3, which would give us directly the h value at negative 3. The k value is whatever we added to it, and that was a phantom 0, which we showed as plus 0, which gives us the vertex at negative 3, 0 right here. That's a good starting point. For this graph, if we wanted to address it right, the a value is 3, which is positive. So we should, and 3 is kind of big, right? So maybe we expect something a little bit more like this. Well, let's confirm some of those values. Oh yeah, the axis of symmetry. So let's draw that line. That's okay. Axis of symmetry, x equals whatever the a value is, the h value in the vertex, which is negative 3. There's the equation for our axis of symmetry. Now x is at negative 3, so I'm going to move 1 to the right, which would be x is negative 2. So in the equation, I'm using the x value at negative 2. So I'm replacing that into that equation, then solving for y, its corresponding y value. So by the order of operations, negative 2 plus 3 is 1 squared. And 1 squared is 1. 1 times 3 is 3. So I have a point at, negative 2 and 3. And just because of the axis of symmetry, that was 1 point to the right of it, so I'm going to go 1 point to the left, also in green. Okay, now the next one. All right, the next value, I'm going to choose, the next point to the right, which is where x is negative 1. So in the equation, I'll replace x with negative 1. So there's our negative 1 in for x. And so I got y equals 3 times negative 1 plus 3 is 2. And that's squared, right? So y equals 3 times 4, which is 12. And we can see right there, it's exponential. So we would expect the values to get farther and farther apart. At negative 112, that's already off of my graph right here. But again, it should help me to at least kind of see what is happening. And then we could go 2 to the right from there on the axis of symmetry. And now, let's go and draw that line. There we go. That's pretty good. Those last two examples were in vertex form, but let's look at one more in standard form right here. We could change it into vertex form, okay, and I think that'd be pretty helpful. So let's go and take the necessary steps to do that. And to do that, first of all, we need to isolate or just separate the x squared minus 10x from the plus 24. Alright, so let's complete the square on this thing. So the b value here is negative 10. Now I would divide that by 2 and square whatever I get out of that. So that's going to be negative 5. That's squared, which is also 25. So I would add that 25 right here. And yeah, we can show that in parentheses, but if I add it, I've also got to subtract it away. Now again, this is nice because from the parentheses, they had plus 25, and that's what's nice about completing the squares. It gives us a perfect square. And inside the parentheses, simplified, we had a negative 5. So that's x minus 5 that's squared. And then 24 minus 25 is negative 1. Once again, this is just helpful because it helps us to find the vertex right away, right? I have a vertex at an h value, which is at 5, and a k value at negative 1. So I can graph that point at 5, negative 1. Alright, and we can show the axis of symmetry if we want. There's our blue line, and we don't really need the equation for it because we're just graphing in this case. But I'm going to move closer to my my y-axis on this. So I'm going to choose my next value at x is negative 4 and put that into the equation. Now I'm not going to use my vertex form because I think it would take longer. I'm going to go back to the original, which is x squared. So I've got negative 4 squared minus 10 times x, which is negative 4, plus 24. Thank you, positive 4. And that would be our y value, the corresponding y value when x is positive 4. Yeah, sorry, not negative 4. So 4 squared is 16, minus 10 times 4 is 40, plus 24. And so y is 16 minus 40 plus 24. That's pretty nifty. Okay. So I do have a point then at 4, 0, which also is the x-intercept. And again, I can reflect that across the axis of symmetry. This one is 1 to the left of the axis of symmetry, so I'm going 1 to the right of the axis of symmetry, which gave us the point 6, 0. Alright, one more point then. Again, I'm going to move closer to my x-axis. So the next point I'm going to choose is where x is 3. And we'll find the corresponding y value for that. 3 squared minus 10 times 3 plus 24. Y equals 9 minus 30 plus 24. So y is 3. So at negative 3, where x is negative 3, I've got a y value. I'm sorry, x is 3, dang it. I got 3, 3, which would be right here. And again, I'm going to reflect that across the axis of symmetry. And now we'll graph it. There we go. Find the vertex, x and y intercepts, and axis of symmetry for this equation. Alright, let's see if completing the square will work on this. Eventually I expect it not to work, and that's okay. But let's see if it does on this one. Now once again, we only do this to see if we can find the vertex. Now when we look for the intercepts, it'll be more helpful to just use the original equation that they gave us. Oh, okay. So our b value in this is negative 5. I need to cut that in half and square it. Now I got a fraction in that, so I'm just going to square both the numerator and denominator, which would be 25 fourths. I apologize, I didn't really need that parentheses. So on this, I'm going to add 25 fourths, but I will also subtract 25 fourths. Now I got that negative 24 minus 25 fourths. If I'm going to subtract those, I do need common denominators. Alright, yeah, let's keep it there then, alright? Let's take negative 96 fourths and subtract our 25 fourths. Negative 121 fourths, just from those fractions, right? And otherwise, we can look at the square that we had, right, from the parentheses. And that was negative 5 halves. And it's just x minus that 5 halves, which is squared. Alright, so we got y equals that. And in the end, we got that y equals x minus 5 halves squared minus that 1/21. Again, this was just to help us find the vertex, which we can see is at that 5/2, and then also at the k value at negative 1/21. We're going to find the x and y intercepts as well. The axis of symmetry is pretty nice, right? Because it's always just x equals the x value in the vertex, 5/2. That should have been negative 5/2, right? Yeah, I should have plus there. Negative 5/2. The x-intercepts are pretty easy, actually, because the y value is just 0. And this equals x squared minus 5x minus 24. No need to complete the square here, you guys. Let's just find two factors of negative 24 that add up to negative 5. Such as negative 8 and 3, right? So that becomes x minus 8 and also x plus 3. But this equals 0 because it's x-intercepts now. Which means that if I can get this x minus 8 to equal 0, I would have a true statement. So x is positive 8. But if I could get x plus 3 to equal 0, that would also be true. So subtracting 3 from both sides gives us x is negative 3. So for our x-intercepts, I got x is negative 3, then y is 0. But also x is 8, and then y is 0. And then finally, I think this is the easiest one of all, is the y-intercept, or intercept, which is where x is 0. So the y value when x is 0, we got 0 squared minus 5 times 0, minus 24. So the y value is 24, giving us a y-intercept. Dang it, thank you, negative 24. Negative 24. You know, 1, 2, 3, 4, 5 answers. Alright, just doing what we've been doing, right? Just to find the vertex on this thing is, well, we would take this negative 3x squared plus the 14x, and then the minus 11 over here. But we need the coefficient of x squared to be 1 when we complete the square instead of negative 3. So the problem with this is if we divide everywhere by 3, we also have y divided by 3 over on this side, which is no good. And that brings up vertex form for, well, finding the vertex from standard form, like this. Bam, vertex formula. The x value is just whatever the b value is, divided by 2 times a, but it's the opposite of that, so it's negative. The y value looks kind of funky because it's a function of whatever the x value is, which would make sense, right? Is if we know what the x value is, then we just plug that value in to the actual equation and figure out what its corresponding y value is. Once again, if a is positive, the graph opens upwards, and if it's negative, it's going to open downwards. Not that that matters when we're finding the vertex. But this negative b over 2a and then the f of negative b over 2a is pretty crucial. Just to illustrate this, right? So if the vertex, if I knew the x value was at 1, then in the formula I would replacing all the x's with 1. Of course, would have the a, b, and c value, and then solving for the corresponding y or f of x value. Alright, so back to this problem. Let's just look at that vertex formula stuff. Here's our x and y values. So let's find the x value in the vertex, or the h value if that's what you want it to be. And that's going to be negative b, which is positive 14, over 2 times the a value, which is negative 3. So that gives us negative 14 over negative 6, which would simplify into 7/3. So in my vertex, I already know my x value or h value, which is 7/3. So the y value is just f of 7/3, which we will find now. right? F of the x value is 7/3. And again, this is just finding the corresponding y value from the formula, right? So that's -3 times 7/3, because that's the x value squared, plus 14 times 7/3 minus 11. Then I'll do -3 times 49/9, and I'm going to change that minus 11 into 33/3, just so I have common denominators throughout. All right, so we have all common denominators in thirds. And, yeah, just in thirds. -49 plus 98 minus 33. So the k value in this is going to be 16/3, or the y value for the vertex, 16/3. Now that was I think that was a lot easier than trying to complete the square from the beginning. I don't know, whatever. Well, that was just the vertex, right? So we need to find the x-intercepts, which we can do with factoring, all right? So the x-intercepts, the y value is 0. So we got the equation 0 equals -3x squared plus 14x minus 11. And we got to multiply the a and b value, -3 and -11, to get, oh, that'd be positive 33 instead. And I need two factors of 33 that add up to 14, right? Positive 3 and 11. So I'm going to not factor yet, but I'm going to break up this 14x, just factoring by grouping, right, into 3x and then a positive 11x. Then we got our factoring by grouping. So I'm going to factor from these first two terms a -3x, and so I've got an x minus 1. And from this other term, I'm going to factor out this one. Factor out a positive 11, which leaves me with x minus 1, which is what we wanted. And then factoring that out, we would get x minus 1, factored from both terms. And then we got that -3x plus 11. Of course, this all equals 0, because we are looking at the x-intercepts, where y is 0. All right, just to finish off these x-intercepts, right? If we can get x minus 1 to equal 0, that would be true. So x would be 1. But if we can get -3x plus 11 to equal 0, that would also be true. So -3x would be equal to -11, and x would be equal to positive 11/3 after dividing both sides by -3. So the actual x-intercepts would be, the x value is 1 and 0, and then the other one is 11/3 and 0. There's our x-intercepts there. Well, then let's look at the y-intercepts, which is where x is 0. We should have only one of those. So the y would be equal to -3 times 0 squared. Not that that's going to matter. Times 14 times 0 minus 11. And yeah, both these terms are going to cancel out because of the 0. So y would just be -11. And our y-intercept then, y-intercept is at 0, -1. I'm a little off today, aren't I? 0, -11. There we go. Finally, the axis of symmetry. After we find the vertex, that's the easiest part, I suppose. Axis of symmetry. Of course, it's always x equals, and then we're just looking at the h value in the vertex, which is 7/3. Axis of symmetry, done. They didn't ask for the axis of symmetry on this. I don't know if that helps or not. We can find f of -4, that's not too bad. So that's just replacing all the x values with -4. So I got -4 squared minus, well, -4 squared. 4 times -4 plus 4. And -4 squared is 16. minus 4 times negative 4, which is negative 16. So that's minus a negative, which will be plus. And plus 4, these two 16s are going to cancel out. And so it ends up just equaling 4 on that part. All right, let's find the vertex. So my first value, my h value, will be the negative b over 2a, right? And I see my b value is this negative 4 here. And then the a value, it should be negative 1 right there. So negative of a negative is going to be positive, and then 2 times negative 1 is negative 2, which simplifies to negative 2. So my vertex, the h value or the x value of the vertex, negative 2. So now I'm going to plug negative 2 into the actual expression and figure out what the y value is then. So that'd be f of negative 2, which is negative of negative 2 squared minus 4 times negative 2 plus 4. So that's going to be negative 4 minus, well, plus 8 plus 4, which is 8. And there is our vertex. The y-intercept is where x is 0. So this is really just finding f of 0. So I got negative 0 squared minus 4 times 0 plus 4, and that would end up being a positive 4. So the actual y-intercept is 0, 4. Alright, this next part you could do by completing the square, which I'm not going to do, just because I think it would take longer. Not that this way is necessarily super fast. However, I like the quadratic formula for this case. So we're looking at negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And we already know the b value is negative 4, right? So we'll replace the b's with negative 4. And then the a value in this is negative 1. Right, if we look up here, negative 1. And then finally the c value, which is 4. So we'll just evaluate this. And, well, negative of negative 4 is 4. Plus or minus, negative 4 squared is 16. Minus 4 times negative 1 times 4 is actually negative 16. But that will end up being plus because of its minus, right? And then 2 times negative 1 is negative 2. 16 plus 16 is 32. Now at this point you could plug this into the calculator because it did say to round this to 2 different decimal places. 2 decimal places. So if you wanted to, right, we could say that that's just 4 minus the square root of 32 over negative 2. And then the other solution would be 4 plus the square root of 32 over negative 2. And from these, let's see, what did I do? So again, we're just rounding these to 2 decimal places. So the actual x-intercepts would be 0.830 because the y value is 0. And negative 4.830 as well. Is if I looked at this and I said, I want to do this by completing the square. Right, I mean you could have taken that 4 and moved it to the other side, so you got negative 4 equals negative x squared minus 4x. But we don't want that negative coefficient of x squared, so that changes all the signs. X squared plus 4x. Then we could take 4 divided by 2, which is 2, and square that, right? So we would be adding 4 right there, and adding 4 here, so we'd get 8 equals x plus 2 squared, right? You could square root this, but you're going to run into that square root problem again, right? that kind of simplifies it a little bit for us. But I don't know, to me it kind of seems like it makes the process more complicated. If you feel more comfortable doing it at that point, that's fine. Now, on the other hand, though, thank you. Yeah, if we were to look at factoring, you're just not going to find any two factors of -4 that add up to -4. So that way doesn't even work, and that's because of the decimal values that we found. Particularly, these are irrational, so I don't know, even finding fractions for them, you wouldn't be able to.